Comprehensions and for loops are the most frequently used language features for performing iteration. That is, taking items one by one from a source and doing something with each in turn. However, both comprehensions and for loops iterate over the whole sequence by default, whereas sometimes more fine-grained control is needed. There are two important concepts here on which a great deal of Python language behavior is constructed: iterable objects and iterator objects, both of which are reflected in standard Python protocols. The iterable protocol allows us to pass an iterable object, usually a collection or stream of objects such as a list, to the built-in iter function to get an iterator for the iterable object. Iterator objects support the iterator protocol, which requires that we can pass the iterator object to the built-in next function to fetch the next value from the underlying collection. As usual, a demonstration at the Python REPL will help all these concepts crystallize into something you can work with. We'll use a list of the names of the seasons, in British English no less, as our iterable source object. We ask our iterable object to give us an iterator using the built-in iter function, and then request a value from the iterator using the next function. Each call to next moves the iterator through the sequence, returning spring, summer, autumn, and winter. But what happens when we reach the end? In a spectacular display of Python's liberal attitude to errors, Python raises an exception, specifically of the type stop iteration. Those of you coming from other programming languages with a more straight-laced approach to exceptions may find this mildly outrageous, but I ask you, what could be more exceptional than reaching the end of a collection? It only has one end after all. This attempt at rationalizing the language design decision makes even more sense when one considers that the iterable series may be a potentially infinite stream of data. Reaching the end in that case really would be something to write home about, or indeed raise an exception for. With for loops and comprehensions at our fingertips, the utility of these lower-level iteration protocols may not be obvious. To demonstrate a more concrete use, here's a little utility function which, when passed an iterable object, returns the first item from that series, or, if the series is empty, raises a value error. This works as expected on any iterable object, in this case demonstrated on both a list and a set. It's worth noting that the higher-level iteration constructs such as for loops and comprehensions are built directly upon this lower-level iteration protocol.